If you look at the current workflow right now, generally what's happening is the design team has this whole huge boulder or like a, and they are carrying the huge boulder over a hill. Then the boulder is being, like pushed over the hill, and then the contractor site takes that boulder again and, climbs to somewhat, taller but same looking.
모스트 보던 팟캐스트.
In a 2017 report, McKinsey ranked construction among the least digitized industries. Yet, we've seen wave after wave of technology. From hammers to power tools, from CAD to BIM, there's no shortage of firms who claim to be innovative, digitally savvy, and data-driven. The latest, of course, is AI. To help us understand what AI's impact on construction could be is today's guest, Dr. Murat Melek. He is the director of Design AI at Suffolk, one of the largest construction firms in the US. With a PhD in structural engineering from UCLA and a master's in data science from UC Berkeley, Murat is a leader in how we adopt this emerging technology. Murat, welcome to the show.
Thank you, Livo. Alex, thanks for inviting me.
So I think maybe we should start with a little context. You started your career as a structural engineer at Arup, which is where you first dove into the world of programming and predictive modeling. Can you tell us a little bit about what technology culture was like at Arup and what drove you towards broadening your technical expertise?
Thanks, Livo. I think my path with Arup is very similar to most of the people in the industry. Late 2000s, early 2000s, started with visual programming when Grasshopper was coming up. Then you hit a wall when the functionality of the Grasshopper, the visual programming is not enough. You say, okay, what's next? You move on to Python. And about the same time also, Arup was looking into big data, data analytics. And decided to have an internal program to train some of the people interested in the topic. So I had my first brush with AI there. Did a predictive model to, hey, if you are designing a high-rise building, whether the core wall system will be sufficient or not. That was the progression from visual programming, Python, to data analytics.
Help us understand why predictive modeling was needed. Like, could you not do the same calculations using, I guess, traditional programming?
That's a great question. And my views on this have changed a little bit, but the main motivation was this, especially in the early design phase. Your fees are not great, you don't have enough time, and the decision you are making at that point has really, huge impacts downstream. So the thinking was, can we use a predictive analytics algorithm to at least start you in the right path? For example, in the case of a high-rise with a core wall system, do I have the right thickness? Do I have the right aspect ratio, the width and the length of the wall?
And just to clarify, Arup is an engineering firm, and presumably you're working alongside architects who are telling you what it should look like, and you're the ones who are trying to decide how do you make it buildable.
That's correct, Alex. And one thing in this whole discussion between the architect and the engineer, that dialogue is generally the architect, like you pointed out, has an idea, draw something up, and there's the engineer in the coordination meeting. You see it and say, okay, I'll get back to you in a week, or I'll get back to you in 2 days, 3 days. But basically that delays the whole scheme, right? We ask the question, hey, what happens if we are able to directly in the meeting tell them, okay, you want to do this, you want the floor-to-floor height to be this much, okay, we need this, the wall will be this thick. But if you change it to a little bit more, the wall thickness will be this much.
Yeah, and I have to say, in my experience as an architect who I've worked with Arup, and I think one thing that distinguishes that company is their ability to be more of a collaborator rather than a consultant, meaning they're sitting alongside with you saying, okay, if you want this is how it's going to have to be, which I find extremely productive. But it seems like you would need both talent but also insight into how construction is going to occur in order to make that dynamic process happen fluidly.
Yes, that's correct. And I think that's one of the things, maybe we'll talk about it later on, which makes sometimes tech adoption, innovation difficult, right? Bringing to the people in different fields, with different expertise levels, with different focuses, together with the people who is actually writing the code, who are actually building the products.
So I guess in this collaborative atmosphere, were you guys at Arup kind of the leaders in tech adoption? Were you guys pulling ahead and kind of dragging everyone else along with you?
That's a great question. I think the Arup is a huge company, like you pointed out, very innovative. But like most companies, this was happening in pockets, right? For example, in LA, we had a really great group of people who was in sync with the leadership as well. Because most of the time when you are doing this kind of things, there needs to be someone up top saying that, hey, it's okay, keep moving on. I'm okay with you being a little bit less efficient for a while trying to build this product.
Yeah, I think that point of efficiency is something we'll get to a lot later in this conversation, especially where AI is concerned. But I guess I want to get to why you took a year off to get a master's degree. It seems like Arup is a big company, very innovative. You have access to a lot of what's going on in industry, but you also have a level of freedom to explore, to learn, and to practice a lot of the things that you're learning. So what pushed you over the edge to take the year off and go get that master's degree?
I was at a point when I made that decision. I was at the give or take 14-year mark in my engineering career. And as I mentioned, I did the Arup Data Analytics program and realized that I like doing this, but I don't know what I'm doing, right? I mean, you can learn from Coursera, YouTube videos, you can read, etc. But really, I wanted to sink my teeth into it. And when I decided to leave and go for the master's program, I wasn't quite sure whether I wanted to still stay in the AEC field. That was, given the experience I've gained, that's what I wanted. But I wasn't quite sure where I was going to end up after the master's program. So we are talking about 2019. I was the only one from the AEC field in the program at that time. I was following two people before me went through the program from the AEC field. So it was somewhat of a, yes, I want to learn more, but I don't know what's next kind of.
I feel that scarcity or the minority of people coming from architecture, engineering, and construction, AEC, as you put it, it seems to be indicative of maybe the slowness at which that field does translate into the digital world, as we mentioned at the top. I'm curious, what was it like being in that academic environment amongst people who weren't just talking about buildings, but were presumably talking about all sorts of digital applications, versus being in the practical field environment where you actually have to deal with real construction, finances, things of that nature?
I think one great part was this. We always, at the silos, right? We attend the same conferences together. We go, and these are great events, right? For example, Rob Otani's AC Tech, or you might want to go to Autodesk University. We are all together learning about what other cool things our friends are doing, but these experiences are limited to our industry, as the endpoint solutions to our industry. One of the best things I got from that program was seeing, hey, how Twitter is dealing with data transfer, right? You are starting to think about data engineering. You are starting to think about user experience. If you ask an engineer with their Grasshopper script, oh, that's the best, right? That's the best. You never think about the end user. Who is going to use this? How are they going to use it? How are we going to deploy it? How are we going to monitor the usage and so forth? That was the best part I got from the master's program.
Yeah, I think being in that educational environment, just the breadth and the freedom to explore is probably still the most important thing about higher education. There's a lot of people who think that you don't need to go to college, or you don't need to get a degree, but that experience is quite unique in our life right now.
Yeah, so I'm someone who kind of took the leap and kind of left the industry, now doing data engineering at Meta in things very unrelated to design and construction. But you came back, you took your learning, you took your knowledge, and you're now applying it to the industry that you started in. So why did you decide to come back?
What I realized was there was a real, and this we are talking this before ChatGPT come along. We are talking about 2020. I guess I was right time.
It's an eon ago. It's like olden times.
Yeah, olden times. But I realized that there is a gap in our industry. So we were in Washington, D.C. back then. I met with Ryan Seckinger from Walter P. Moore, and the idea of applying what I have learned at UC Berkeley, in addition with the experience I had, was really compelling. That was the reason. Okay, I want to stay in our industry.
Yeah, so especially with AI, we seem to be at a moment where technology is moving really rapidly. You hear new developments about AI all the time, like the latest with ChatGPT 4.5, and then now diffusion, LLMs. It's just every week is something different. But the construction industry continues to stagnate. From your perspective, what is that core problem that we're facing that causes our industry to move so slowly?
One thing is risk mitigation. We somehow fragmented the whole process from early design initiation all the way to commissioning into small bits of fragments with different stakeholders, with different taking care of the risk from their end. But those siloing, those fragmentation is not very conducive for really coming in and making the whole process efficient. If you look at where the data is starting from design initiation and how that data is trickling towards to the end, from estimating to procurement to commissioning, it's not a pipeline, it's not a highway, it's a goat path, going from a mountain. I think, Livo, especially with your experience on the procurement side, really lots to do in that entire ecosystem.
But it's interesting because you look at other places around the world who construct with much more humble means, and they're able to build things much more quickly. What is it specific about the United States or the Western world that makes it so hard to actually get things done? I think that's a question on a lot of people's minds, not just architects and engineers.
I'm originally from Turkey. For example, going from the design side, a designer generally produces, if we are talking about reinforced concrete building, they produce all the way up to each rebar, how it's going to be bent, how it's going to be, what's going to be the length of each rebar. Here, there is a certain cutoff, right? Okay, this is my design intent. Now you take over and create the fabrication shop drawings for me.
So the role of the architect in other places, in Turkey, for instance, is much more involved in the entire process versus here. Yeah. You have the architect who says, this is what it looks like. The engineer delivers that or translates that into something that can be constructed.
So I guess maybe this is actually a question for you, Alex. You're an architect. What is it about architecture here that's much more focused on the design, the glamorous renderings, than about actually being what we talk about a lot, the master builder, someone who knows and manages the end-to-end process?
Yeah, indeed. I think it's a little bit like doing exercise without actually understanding how to do the movements. Meaning you don't really know why you're doing this. You just know that this will help you lose weight or this will help you get fit, but you don't really understand how it fits into a larger, process, how it changes your body. And so in the case with architecture, if you're not building with material in mind or assembly in mind, yeah, you can create beautiful things. And by the way, with technology these days, you don't need to know those things. Like you can just put something into a 3D, draft something in 3D software and make it look beautiful, agnostic of cost or of gravity or of what your contractor is going to say to you. But at the end of the day, you do need to deliver. And I think this is one of the issues too, is we don't really focus on the product. We focus much more on this process and don't think about outcomes. So when you probably don't encounter an engineer until you land your first job, and then you're sitting across a boardroom table with them and they're telling you this can't be done. We need to fix this. And you're saying, what do you mean it can't be done? I designed it that way. So it is a little bit of an issue, I would say, in terms of delivering projects, but it's what Murat, you were mentioning. There's that you have to bring multiple parties to the table, and it's about how you create that communication as well.
And, I think that one of the promises of AI, at least the connectivity, is that multidimensional thinking, right? The same goes for, Alex, what you have described about architects also goes for engineers, right? Okay, I'm designing this way. I'm going to use this. I'm going to detail this beam, I'm going to put this rebar, etc. But is it really constructible? Or similarly, is this really the cheaper solution for the contractor to put things together? I think that connectivity enables that, right? While you are, as an architect, deciding where should the window go, at the same time, the engineers trying to design the building, but somehow thinking about schedule impacts, estimation impacts, procurement impacts.
Yeah, and I think that one thing that is potentially helpful on this discussion about AI in construction is forefronting cost. Because if there's one thing that we do need is some sort of currency that says, okay, how do we get the greatest impact for our resources? And usually that's a dollar and cents figure. Now, a lot of architects will say, well, there's a lot of things that can't be measured financially or in terms of money. But at the same time, it's not your money to spend usually if you're not sponsoring the project. So, a lot of these discussions, I think, about efficiency boil down to what can we get out of our resources available?
So I think efficiency is one of the reasons why companies say a lot that they're adopting technology. But I think, as we know, many companies like to talk about how they're data-driven, how they're innovative, and at least from my experience, a lot of that is a lot of smoke and mirrors. And when it comes down to the actual work, it's a lot of spreadsheets and a lot of PDFs. Why do you think it's so important in our industry to give the impression that we're innovating and adopting technology when in actuality, the work itself is not moving in that direction at all?
It's a difficult question. Some of it is, I think, marketing, right? You want to, you want to be seen as innovative. In addition, we want to attract the best talent, especially, given the environment. If you're a young engineer, young architect, learns how to code, getting better at it. They look around, should I stay here? Should I go to another innovation company? Generally, go to a tech company and so forth. But some of that is, like you mentioned, Lebo's smoke and mirrors, so the marketing side and talent attraction side.
So Suffolk did attract you, someone young, someone talented, to go work for them. For people who don't know, Suffolk is one of the largest construction companies in the US, doing around $6 billion of business a year. You're moved from engineering to construction. So why construction? And can you tell us a little bit about what Suffolk does and where they're building?
Sure. We are a general contractor based headquartered in Boston, but we have a relatively big presence in Northeast, including New York, Southeast Florida, California, Midwest. And the reason why I decided to make the change from consultancy to contractor side goes back to the availability of data. When you are working for a consultant, you are holding one piece of the puzzle. You have control over that segment. But for example, you don't have access to procurement data. You don't have access to the impact of your design into scheduling or cost. So when I saw the job posting for Suffolk, basically I said, okay, this is the chance for me to really have an impact, not only on the design side, but in the entire ecosystem. So that's why I chose to join Suffolk.
Do you mind, though, Murat, explaining to us why data matters so much in construction? Like, how much data are we dealing with when you're talking about building a building?
Great question, Alex. First, if you like, I can talk about our approach to data. So that might give you a sense of the magnitude of data we are dealing with. We started our data journey, give or take, 7 years ago. We have a dedicated data analytics team, a data engineering team, and visualization team. And we started with a Databricks data lake where change events, change orders, RFIs, things of that unstructured data is flowing in. Right now, we are sitting on a trove of data. I was just looking at the number of PDF drawings in Databricks. It's 500,000 at this point, sheets of drawings. We can talk about PDFs only, but just as a metric. The question why data is important is we are a large corporation, and we are the quality of work is very important for us. We have our own metrics to monitor, both in terms of budget, both in terms of quality, safety, and that data needs to be made available to different stakeholders, all the way from CEO to the project teams in different granularity, right? So one of the big perks for data for us right now is our leadership is able to see from 50,000 feet which project is going okay, which project needs a little bit more attention, which project is doing very well. Same for the project executive teams, more granular details. Hey, take a look here, pay attention here, there is a yellow flag here. That is wholly enabled by this data ecosystem, which is, refreshing it, constantly.
And I just want to frame that the data we're talking about is about real world events and materials and elements. It's not the data that we often hear about, like our personal data that gets mined by social media companies. Like these are things that are happening, either planned to be built in the world, or when you talk about RFIs and change of order events, like those are things that are happening on the construction site where they need to change what has already been planned. So, it is a little bit of a different type of data than I at least am used to thinking about when it comes to big data. But when you think about a building, all the decisions that have been put into making something in place, either designed by the architect and the engineer or maybe sort of improvised by the contractor, there are a ton. There's a lot. And they continue to grow as the building gets used. So I think the next question is, and you mentioned your leadership, how they have a sort of concern about what is going on from a 1,000-foot perspective all the way to the site itself. John Fish, your CEO, is quite renowned for being quite a pioneer in the industry. What do you think he saw in data and making sure that Suffolk doesn't remain stagnant, in fact, becomes an extremely innovative construction company that has led you guys to function this way?
John Fish is constantly thinking about the right now, but the near future as well. And when you look at, the view is not very optimistic, right? There is labor shortages, material prices, uncertainties, given the political climate, but also economical wind forces. If you look at from the problems generally we are getting in terms of coordination or lack of information, things are not improving. And I'm talking, what I'm saying is independent of any McKinsey report, productivity things, but really on the ground, he's able to see the issues. What he did was first form the team around him on the C-suite level, our CTO, Jitki Chen, the right people at the group of people, and he sees the importance of this, need for improvement and pushing for it.
So I think we've laid a lot of foundational concepts and understanding of where we are as an industry, where your role is. I think we should move into what I think is, for me, the most exciting part of our conversation, which is diving into the data. One of the things that really, I think, changed my mind in my data journey was the difference between structured and unstructured data. I think for a lot of architects, a lot of designers, data is data, right? You have all these PDFs in your drive, you're data driven, right? You're using Excel to, calculate material costs. That's also data, right? But can you help us understand, what is unstructured data? What is structured data? And how do you go through 500,000 PDFs without hiring, 1,000 interns?
Great question. I think the best example of unstructured data is RFIs. Because if you go to different regions that
I
we
just want
work
to point
with,
out, request for information.
Request for information. Thanks, Alex. If you go to our different regions, different projects, different superintendents, when you look at the RFI data, both the question, request for information, both the question and the answer is pretty chaotic. It's basically someone is typing a question and is an answer coming back. That's unstructured data for you. Going back to structural engineering, for example, let's say I have a column schedule. I have my steel columns, mark, column 1. It's a W14 by 90, and its length is 15 feet. So the next column. So you can think this like an Excel table. That's your structured data.
But I guess why is it so important to convert one to the other? One of the examples I guess I can think of is if you have all these RFIs, you might want to ask questions. Is okay, what part of our design is the least clear to the people that we're handing data over, right? Maybe we do some sort of analysis and say our steel components are getting a lot of questions. How do we improve that aspect of our information delivery in order to rectify that? So when you are sitting on this mountain of unstructured data, how do you start looking for those clues hey, this is an area of improvement we can work on?
First of all, like you pointed out, Libo, unstructured data by itself is useful in some manners, but for the use cases like you have described, it's by itself not powerful enough. First of all, let's think about a building, and I have this tons of RFIs for hospital projects, and I'm looking in the hospital. Or if I don't have an understanding of where this RFI generated, for example, going back to the BIM data, if the connection between the RFI, the unstructured data, has no connection to the structured data, the BIM data, it's not very useful, because what I am getting, let's think about this case, right? I have past experiences, past problems, I have past projects, the BIM data. What I am receiving right now is new BIM data, new project data. The terrible things haven't happened yet. So I'm trying to predict the terrible things by looking into the structured data, the BIM data. In order to be able to have that predictive analytics, you need to basically connect the unstructured data to the connected data.
It seems like we're also talking about some of these recent innovations in design and construction, one of which you mentioned is BIM, so building information modeling. And when I think about BIM, it seems like it was this moment where the industry started to say, okay, instead of just drawing what we think the building is going to be, we're actually going to create a miniature digital twin of it, and we're going to model every single element within it. And that element is going to have information. So instead of drawing a door, which is 4 lines, we're going to actually have a component, which is a door. And that component is going to have its materiality, size, its make and manufacture potentially. And that's a better way to communicate between the contractor, the designer, the engineer, et cetera. The whole team can be built around it. But what you're saying is that it still had limitations, meaning you still were combining old school methods of analog documentation as well as old school methods of analog recording and then trying to combine it with BIM. So is that a major log jam that we have right now in 2025? Is that something that you guys are working towards? And I anticipate AI will help improve that sort of fluency?
Alex, a great question. If the problem is even worse than that.
Oh, no.
So I think BIM was a huge promise for us, right? We are going to be data-driven design. Instead of sketching things on CAD, on a 2D, you are going to build a 3D model that will include the data in it. When I look at the building information models we are receiving right now, it is far from that. You might see inconsistent element definitions. For the first 3 levels, you might see, for example, partition walls named one type. You go to the 4th level, suddenly that changes for no reason. Maybe someone else was modeling that piece. The information fields are sometimes full, sometimes empty. So even before that design intake for us, the one I described, predicting whether I'm going to have any troubles, first we need to make sure that what we are receiving is, you might say, conditioned or transformed, cleaned. So if you look at the current workflow right now, generally what's happening is the design team has this whole huge boulder or and they are carrying the huge boulder over a hill. Then the boulder is being, pushed over the hill, and then the contractor side takes that boulder again and, climbs to somewhat, taller but same looking hill. So yes, I mean that's the aim, but that data connectivity, that data highway is not there yet.
And just before we move on, there's a lot to discuss here, but why do we care? Why would the average person who isn't involved in AEC care that this process is going smoothly?
Because of schedule. Every day a project is delayed. Every day a project is longer. It's a lost opportunity cost for the developer, for whoever is financing the project. Most of the cases for the design, I think more than the fee itself, the issue is the quality and the time schedule. High quality and quick delivery really opens a lot of doors.
Okay, so we have stronger connection between the designer, the contractor, the engineer. We'll have better quality projects. We'll have projects that cost less, and therefore we can presumably have a better world to inhabit. I totally buy it.
I think it's important also to hit on here that there's a lot of rework happening. When the designer pushes the boulder over the hill, it's rolling back down the hill before the contractor pushes it back up. So you're losing all that effort.
I thought you were going to say that this boulder is going to steamroll the contractor. They're going to have to pick themselves up and fix everything.
Yeah, I mean, there are many reasons from trust to, legal requirements to, again, what the contractor is expecting is a certain level of LOD. Not all trades, not all consultants, not all architects are going to be able to deliver to that one.
LOD?
The level of development, Libo can correct me here. But, LOD basically defines how much information is in the model. For example, at a schematic level, at LOD 200, you might see column sizes, slab edges, some sense of, for example, in the structural sense, material quantities like, per cubic yard, you are going to have this much rebar, etc. When you go to LOD 350, LOD 400, now you have fabrication level details ready to construct, all coordinated, all the pipes are there, all the ducts are in the right place with quantities.
Yeah, I think that's an important thing, for listeners to understand is that the model in its original sense, maybe pre-BIM, is just kind of lines and shapes, and it needs to be interpreted into a building. And that's a lot of what's happening through engineering, through kind of the contractor process is, hey, you want to build this thing, this is how it gets assembled. But with BIM, you can start defining those components very early on. And as you work through levels of detail, you get to a finer understanding of what that could be. You might even get down to the nail and be able to say, hey, I'm using, I don't know, 10 million nails in this project. And you can then calculate costs, understand schedule, and work off of that data. But I want to go back to something you said about trust and kind of the legal framework. Those are things that maybe are not able to be innovated on by technology. So are we still at a place where what's blocking innovation is that inherent trust and the legal framework that we're building under?
To some extent, yes. For example, we are a contractor, we are receiving a BIM model from in an architectural firm or consultant. First of all, are they going to release it to us? Secondly, when it comes to our side, are we going to say, okay, we are sure they did a great job, let's just start building on top of this one? I don't think that the trust issue is going to be resolved overnight. On the legal side, I think AI has some contractual language. Here, I think where the AI comes in, and this is what some of the work we are doing is, I want to use that model. I know I can trust it 100%. Can I use AI to at least put some guide rails around? Hey, any red flags, any yellow flags. If there are any missing information, missing gaps, can I fill them automatically? And if there are inconsistencies, like the one I mentioned, different definitions for walls, can I fix it on the go without someone needing to open the model, go one by one? Can I do it programmatically with the help of AI? I think that's the solution. We aren't going to suddenly say, okay, we trust everyone, we are all friends. I don't think that's going to happen.
Maybe to set us up for the next part, the AI part of our conversation, which I'm sure all the listeners are waiting for us to get to. You mentioned earlier that part of the reason why you come to Suffolk was because of the amount of data that Suffolk has. Why is having that large volume data important for AI?
Let's take the Netflix example. When I open up Netflix makes suggestions to me on, hey, Murat, you would like this movie or this movie. It's not that Netflix has a lot of information about me, but Netflix have a lot of information about people like me in my same gender, same age group, same location, etc., etc. And that goes for the AI models we use in AEC as well. You need lots and lots of data. If you are just, let's say, you are on the structural engineering field, you are trying to come up with an AI model that designs, let's say, a brace frame. You can generate synthetic data because you have simulation software, you can run it over and over and over again. You are able to create this clean synthetic data to model your building.
And just real quick, synthetic data is data that's generated by the computer, so you don't need human interaction in order to generate that base data.
Yes, thanks, Libo, for that. The next step is the human factor. With synthetic data, computer generated. There are in other industries there are cases where synthetic data is used to generate human kind of behavior as well. But when you are talking about problems on the field, constructability, etc., 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 as this multi dimensions increase, you are no longer able to simulate this in a computer environment. And then if you are unable to create this synthetic data in this simulation environment, you are just restricted to the data you have. That's where having a data lake, having this large data set sets you apart from others.
So how are you using AI to, I guess, translate and process this data? Is it like an LLM?
Great question, Alex. Without going into the secret sauce, right? Let's first of all, before you start in any AI project or any development project, you ask the first question: what's the problem? Right? The problem we are saying here is, I'm receiving design from someone. I don't know how complete it is. I don't know whether there are any coordination issues with that. The question is, can I use AI to give a score to this design for me? Right. So when you look into this problem, there are several parts to it. One of them we discussed, data cleanup, data standardization. Here, really, AI shines. Why it shines? Without going into too much detail, is very good at, let's consider two examples. One of them is rule-based. One of them is, Alex, like you pointed out, LLM transformer-based approach. In the rule-based, you are saying that if you receive, let's say, this VAV box, I want you to check, whether this parameter is in there. If that parameter is not there, give me an error or fill it out. If this naming is not right, what I want, let me know, etc., etc., etc. Let's stick with the VAV example and let's stick with the name. I know that I have a catalog of VAV boxes over there for procurement or estimating. I'm receiving a strange name that I think it's VAV, but I can't be sure. And I don't want someone to go in and check it manually. The large language models are pretty good of understanding that, textual input. And, of course, with some development mapping into what you actually have. That's a good example of where AI is being used in the standardization phase. Of course, you need to do many more of these things. In most cases, off-the-shelf LLM models or LLM endpoints are not going to work for you well because they are not developed for AEC industry. There are some great startups like Trunk Tools. Their model works very well. But you also need to come up with your own custom solutions based on the problem you are trying to solve. That's one part of AI in the data standardization. Once your data is standardized, and Alex Lebo, please stop me if I get into a rabbit hole. So once the data is ready, standardized, now you need to map it to the past problems you have. If you can think this as, every time I see in a hospital building, this element is together with this element, or this information is missing, not filled out, we got a change order. That's the second thing. So by aggregating all that, even in the design intake, you can start raising yellow flags, red flags, so that you can direct your digital engineering team and design management team to those areas.
I think hospital is a good example of a program type that you're applying this to. Can you also talk about other building types that you're using this for, the scale and the investment that's involved in these projects?
Hospitals are a great product, and I'm going to be perfectly honest, hospitals are tough. Right, so we started with something somewhat easier to do, like the lab spaces, tenant improvement spaces, office conversion, etc. Even though the construction trends are low, going down, it's the area where it's easier to test your ideas.
I think what I love about your perspective on AI is you're not saying, I hate it when people say this, like, oh, AI is just a cheap intern and you just can now hire thousands of them to do whatever you want, right? You're very precise about exactly where it applies and why it's helpful. So can you, I guess, take us through your perspective? How do you pick the problems that are right for AI to solve? And how do you then know what approach to take in order to try to solve those problems?
First thing you need to accept is AI at the end of the day is probabilistic based, right? So there is an inherent error with it. And as you chain one AI agent or one AI function after the other one, you are basically chaining together that uncertainty and increasing it, right? So you need to select and use it sparingly. The first question we ask is, hey, is it easy to get to a rule-based solution for this specific step? If that's the answer is yes, we use a rule-based solution. Either we develop it internally or we look outside for partners that we can partner with. One of the great things about working with Suffolk is we work closely with Suffolk Technologies. They are an early stage fund for the startups in the AC industry. So we see who they are working with and we partner with those companies as much as possible. So that question is, hey, is this rule-based? Okay, let's do rule-based. If a rule-based approach is not possible, meaning the problem is too multidimensional, the problem needs some kind of creativity or some kind of, initial judgment, then we select the AI solutions. Of course, the question then you are going to ask is, do I develop it in-house? How much it's going to cost me? Is there an external one out there from one of the big ones, by Microsoft or others? Or do I go with a startup that has the solution?
I think that ROI question is really important for us to talk about, because for a startup, adding AI to the process has great ROI because, VCs love to invest in any startup that now has AI. But for an established business, as we know, construction works on very thin margins. How do you calculate the ROI on some of these initiatives and investments for your executive team? I'm expecting that they want some sort of feedback on that.
That's correct. We have to show ROI and we have to show progress constantly for the leadership. And I think what's one of the positive things is always you need some kind of heat under you, right? I need to ship, I need to develop. So same goes with partnerships with startups as well. The question we ask is, do they have upward potential? Secondly, is the idea novel and can it be deployed? Can it be shipped? There are certain criteria we use, but Libo, that's always a question.
I think you mentioned a lot about these piecemeal solutions where you prevent that error from stacking up because you're containing it in a very narrow frame. What are some things that weren't possible with AI before that is possible with AI now to kind of help our listeners understand maybe the seismic shift our industry is about to go through?
Let me give two examples. I'm going to start with the boring one, the guide rails. For example, I might get a call from Chase saying that, hey, someone just used your credit card in Puerto Rico in a gas station somewhere, right? How does the credit card company knows that? It's basically the AI algorithm is seeing whether there is anything out of the ordinary, anything out of the benchmark band. If you have enough data, if you can benchmark your past projects, past activities, you can use AI to see whether there is anything testing those benchmarks and raise a flag. It again goes to the multidimensionality of the problem. Human brain cannot comprehend that, right? But AI can, constantly on the monitor. But that's the boring use case, super useful, very, very doable AI, right? The second part is, I think the greatest ROI is the creativity part. And I'm not saying like getting the job out of basically making the engineers or architects lose their job, but helping themselves. For example, we work with a startup called Genia, and they are a structural engineering startup, and their thing is you give, let's say, the layout, and it will generate the structural framing for you using AI, in the background. Of course, what add values for them is once they generate it, of course, they have a rule-based algorithm in the background, making sure that what is generated by the AI is correct. So to your question, I hope I didn't sway too far away. Two things, seeing where we are going, but in the more creative ways, make sure that whatever is being generated creatively is followed by a rule-based check. Okay, you created this for me. Does it make sense? Is it passing the master test?
But I think that's interesting because if you think about our jobs, either as an architect or as an engineer, I think we're often attracted to the latter example that you gave, the kind of sort of generative, creative aspect of the job. But then a lot of it is also like making sure the thing doesn't fall down aspect of the job too, like doing all the nuts and bolts, all the minutia that is involved in creating a building. So it's interesting to say that AI also has that bifurcation in responsibility and occupation, that it would be able to do both and presumably augment the human mind, not replace it. I am also interested too. Now we're talking about generative AI, in the architecture fields, and I'm sure just in the world in general, we've seen DALL-E, we've seen Midjourney come out, being able to generate images of things, but oftentimes buildings too. What I've always said about those types of models is that they're simply projecting a picture. There's no structure, there's no space behind it. You're talking now about startups that are able to generate, let's say, a structural response to a space, to a thing. Do you think AI can think spatially?
Great question. At the end of the day, sometimes we like to think AI like thinking like us. But the first thing we have to accept is AI works completely differently. To your point, right? When the genius algorithm is laying out, let's say, the beams and girders, it doesn't necessarily think that, oh, here's a column, I need to go from here to here. It's basically, like you say, mimicking the past information, how it should look like, but that doesn't necessarily understand the logic behind it, right? That's why, you need a rule-based check. Same goes for if you think about the ducting problem, right? Taking one duct from one end to the other one. And let's say you want to really go super high tech and you are going to do reinforcement learning. And I'm going to tell you very quickly what reinforcement learning is and why this problem ties to your question, Alex. It's just like self-driving car, right? In self-driving car, you are thinking it needs to go from point A to B, but at the same time understand its surrounding and take actions. There's someone in front of me, I'm just going to swerve left. So if you look at, for example, that's reinforcement learning, right? It's basically the agent, the car, makes a move, and then it's getting a reward back, positive or negative, and starts learning from those reward functions, right? If you look into the duct layout problem with reinforcement learning, it knows it needs to go from point A to B, and it knows that there are obstacles, right? It's like a computer game. It needs to duct under the girders, etc. It doesn't need to stop. So it can go straight, it can go left, it can go right, and based on what it's doing, it's getting rewards, positive or negative. It is that level of AI is very, very hard. Yeah, I mean, you need to spend a lot of money, a lot of compute, lots of training. I mean, that level of AI that understands its environment and reacts to it is very, very hard.
I guess, and that's why that sort of AI is being applied to cars, because it seems like there's a clear market for that, probably larger than designing buildings at the moment. I imagine we'll get there, but what's interesting to me about this conversation is when I think about it, if I design a building, I'm sure you're the same way, we're designing based on our bodily proportions. Like you think about Corbusier modular, right? Like you have a certain height, that's a person's a certain height, and you have relationships to your walls, your ceilings, your windows that are based on the human height. If we are all 2/3 of our current height, if everyone is 4 feet tall, our buildings would be smaller too. Yet AI doesn't have a body. It doesn't have space that it can interact with. And so I wonder, this is just like a thought, how one would feel if you are a disembodied entity while designing a space for people to inhabit in their own physical body. I think it's a fascinating question, but maybe we haven't gotten there yet.
Would we expect an AI designing buildings to even design buildings for humans? Because there's a lot of buildings that don't need humans now, right? Like automated warehouses, data centers. They're very computer or robot centric. And we're at this phase now where buildings are no longer exclusively machines for humans, I guess. But one of my takeaways from this is that designing a duct is just as hard as designing self-driving cars. And I think that's something that's actually really incredible, is like that piece of seemingly simple human action is incredibly hard. Difficulty matching what billions of dollars have been invested in just to get the driver out of the seat. One of the things I think I want to go back to is we talk a lot about risk. We talked a lot about the fragmentation of the industry. We talked a lot about how communication is not this super highway. One of the other aspects that's been discussed a lot is how AI is going to disrupt the business model across the value chain of AEC. One of the examples that is given a lot is, hey, now that we can design faster, maybe we'll get a much compressed version of design, and maybe architects and engineers can get paid more by delivering designs in a shorter amount of time. But that works completely opposite of the current business model, where you're charging for hours, and the longer you take, the more manpower you use, the more you get paid. So what are some of these disruptions that you see on the precipice of the industry adopting this technology?
That's a great question. Let's first talk about the current state, right? If you are looking from the design side, the fees are tough, the schedules are tough. If you are an engineer just starting to work as an engineer or an architect, you are not paid very well, you work long hours, and generally the solution to this problem is outsourcing. More and more design firms are opening up, new branches in areas where they can pay less for engineering work. So the current state, I don't think that is anything where we want to be as the industry. Looking from the developer side, if you talk to developers, they think that the quality of the design is slipping, it's taking too long. They are okay with getting a quality design in a much shorter time frame for the same price. So to your point, I think the only solution to that is going from an hourly-based approach to an outcome-based approach. Hey, I'm going to give you your CD level drawings and maybe more, right? Start of the digital twin, whatever you call it, or fabrication-ready models, or something that connects directly to your contractor, so they don't need to start from scratch. But this is how much I charge.
But I guess, Alex, you're an architect. Is this something that you're looking at in terms of how you think about how your business evolves into this future?
Yeah, absolutely. I think one thing that I'm privileged to be in is I've seen through my education, I've gone from analog to digital, and now we're going to, I don't know what you call it, hyper digital, like where AI can really contribute. So when I work on my projects, we're trying to be leaner than in the past. I think in the previously we would try to bring in a lot of architects to work on some of these projects, and now we would say, like, is there a solution that can help us not hire somebody else? And now that sounds kind of austere and maybe a little bit like not so nice, but we're working on very thin margins already, and so anything that can just improve our productivity and our efficiency, we can reinvest either as money back into the company, or we could reinvest it into the design and just make it better too. And I think that this is something I'm seeing a lot. There's a discrepancy in generationally. Like you have some people, some of my colleagues at the university, for instance, who I think are a little bit concerned about AI's influence on design, meaning it's going to, they have the more like worry that it's going to become much more agentic and it's going to be the one that's driving the design, versus I think my generation, Libo, you and I, and Murat too, probably, we feel like this can be an aid to us. This can allow us to do the things that we want to do and free up our time. I mean, I'm sure the three of us can sit down and think about all the times we've missed an event we wanted to go to, or didn't get to go home and have dinner with our family because we had to sit there like making PDF, copying lines, like making sure that the model was right. You know, like all that time could be saved, and that could be reinvested into your personal life, but could also be reinvested into the project. So when you're talking about, Murat, you're talking about we need to go from an hourly model to an outcome-based model. It seems like it's also the inverse of what a lot of the software companies are doing, which is they used to just give you the license and then they transition to a monthly subscription. So if they can do it, I sort of feel like our industry can also make that change, and everyone can accept it at some point.
So I think that point of optimism is great for us to transition into a much future-looking part of this conversation. As we know, construction costs has just been going up and up for a number of reasons. Yet at the same time, we're facing a ton of issues that we need buildings to solve, right? Housing, electrification, data centers, and AI, right? We're spending enormous amounts of money to achieve much less than we used to. So, Murat, you being someone who's applying technology, who's in construction, who understands the nuts and bolts of this, is there a future where the cost of building doesn't continue to go up and we get further and further away from being able to use building quickly as a tool to improve our society?
I think it will need to change, because right now I think we are at a point where nearly the cost of building a building is about the value you are generating by building that building. And if it goes this way, you are right. I mean, it's not going to be logical to build, for a developer to build new buildings. At the same time, we are seeing a high level of, there's a housing crisis. People out on the streets without a place. Housing affordability is getting more and more difficult for not only for normal people but even for professionals, right? So I think this needs to change. Then the question you ask is, how can you do this, right, in the short term? The tail end, the downstream tasks of construction, it is hard. I don't think that robotics is going to come and change it overnight. There are many reasons for that one, but we can start with the way we design is not standardized, right? The type of workforce we use, the type of relationships. I don't think that's going to happen very soon. But we really have a chance to really improve the way things are done in the design and pre-construction phase. Really, the fact that the design is generating this wonderful data for design, then it goes to trash. Then someone else is regenerating that data in a somewhat similar format, but in a different level. The need to do this manual checks over and over and over again, or building this 3D complex models by taking too much time. All of these things, if you can start improving these processes, the efficiencies will have a real impact on everything.
I want to make a connection here, which is we're talking about construction, but the other side of this is permitting and policy, meaning there's an authorizing body that needs to allow you to construct the project. We've talked about this on the podcast before. I think a lot of the inefficiency that we're seeing in society that's leading to this housing crisis, that's leading to this sclerotic construction scene that we have right now, is because there isn't a lot of pressure being put on authorities to actually start construction. Like if you need to wait 2 years before you can even put a stake in the ground, you're not going to try to be efficient in that time period. And probably from the contractor standpoint or the engineer standpoint, they feel like they have a lot of time to fill. What's the name of that law? It's like you will take the amount of time it takes to do the job. As much as you're given, you'll fill up that time, right? Like if I know I need to produce something by the end of the week, I'll take up the entire week to do it, versus if I know I need to do it by tomorrow. So I do think there's also, an interesting reciprocal relationship between construction and I think broader policy, none of which we have direct control over here. But I would say if people started to implement shot clocks saying you put your permit in, once the permit's in, you can start construction, that would put some upward pressure, I think, on construction and design to actually be a little bit more efficient. That's what I would hope, at least. Do you guys see a connection there?
Yeah, I think the permitting, exactly, yes. I'll completely agree with that.
I think the time factor is huge, right? If it takes you 2 years for shovels to hit the ground, that's a lot of risk for contractors, right? Material costs are constantly fluctuating, labor costs are constantly fluctuating.
Interest rates.
If I'm trying to promise you a cost and it takes me 2 years to actually then start building to actually realize my promise, I have to inherit a lot of risk, and that's going to cost you ultimately because I have to hedge against that risk.
Yeah, I mean, I think that's a major issue. It's sort of like large scale procrastination, right? Like we're just putting things off, like leaving decisions for another day. I don't think it makes us feel like a very dynamic society. So I'm all for construction because I feel like when you see a construction site, like you go to New York, I mean, Libo, when we record, it's sometimes hard to get the audio because there's always like some building being built across the street from you. Like there's some energy that's there, and I think that would be good for the world.
Yeah, and to that end, let's think about the current way we design buildings. There's this schematic design, DD, CD, right? You wouldn't dare buy, as if you were a contractor, you wouldn't dare buy things using an SD level drawing, right? But if you look at, for example, and I'm going to go with structural engineering notion, by the end of SD, like a big portion of the design, you already know what's going to end up in CD level. So really, there is really not keeping you from divulging that information to the other stakeholders. The only thing stopping you is risk.
Yeah, well, it seems like speed is fundamental. Like, what's a John Wooden quote? Like, move fast, but don't hurry. You gotta make sure that you're keeping up with the right pace. But the other thing too is, design happens on one schedule, as you mentioned, schematic, design development, CD. Developers don't think that way. They think in terms of permitting. They think in terms of getting the site permit and then the building permit and then all those sorts of things. It's a totally different phase that's a little bit out of whack too. And, talk about another misalignment in the industry. There's all these different people who are speaking different languages. I do think that if we could bring everyone speaking the same language, it would be better.
I know we try to gravitate towards optimism, but we always revert back to this pessimistic view of our industry.
I think it's a sober view, though. It's a sober view, right? Like, we're dealing with real stuff.
It's true, but as someone who's maybe a young person who's going to school right now, who's really optimistic about their future, reality hit all of us in the face when we came into the professional world, and we took various different paths in order to find our place in this industry. What would you say to, I guess, that young person who's right now super optimistic, who's looking at this and saying, hey, I can do something to fix this? What do I learn? Where do I go? What is the best next step for me to take?
I'm optimistic in that sense. If you are making the right moves early on, you are a young graduate just coming out of an architectural school or a bachelor or engineering school. Because, I'm going to give you a concrete example. We just hired a data engineer. We were looking for someone who had BIM experience, so who understands the inner workings of building information models, but at the same time is good with data engineering, good coder, etc. We received hundreds of applications. We had some very good candidates, but when you look at the overall band, you get either people who can code or people who can do BIM. The people who can write code and have domain understanding are not that many. Because I think, Libo, to your example, the great ones moved to Meta, Google, and other startups, right? So if you are passionate about the industry, if you like the construction industry and you are gaining this domain understanding, right? For example, Alex, to your expertise in architecture school, I'm sure you are learning why you design certain things a certain way, that philosophy behind it. So you are coming that route, but at the same time, if you can augment yourself with, you don't need to learn everything. Some niche, right? Either user, interface, user experience, or data engineering, how AWS or Google works, or some kind of programming language. One thing is that with LLMs, I think one of the greatest things is right now, especially with the latest ones, it's so easy to write codes if you know what you are doing, right? If it's much easier to ship things. So I think being able to look holistically into the big picture, hey, this is the role I want. Maybe looking into some of the job postings people are posting, hey, this company is looking for an AI engineer, this company is looking for a coder. If you are that kind of person, I think there are so many things to do.
I think one thing that Murat said I want to emphasize is go forth and learn that little thing. I always like to say now is always the best time to learn how to code. And learning to code has been this huge unlock for me, not only in my ability to implement things, but also just the kind of culture and amount of knowledge sharing and the amount of understanding that's all out there, because the software engineering industry just works quite differently from how architecture, engineering, construction works kind of as a culture. But like you said, with LLMs, whenever you're stuck on a piece of code, whenever you get a bug, you just punch it in and it'll tell you the answer. So you're not dealing with, I'm sure you and I have done this a lot, which is like, I don't know what this Revit error is, and it's taken me 3 days to try to figure this out, but now you can probably get that answer within a few hours. So really, I mean, I guess my turn to give a piece of advice is just go for it, right? If you're interested, if you're curious, just do it.
I saw you learn to code, and it was incredible because you just did it, and you didn't have LLMs to back you up. But yeah, I completely agree. I feel like there's so much room right now to make greater efficiency in the built environment, and no one's going to tell you how to do it necessarily, but if you can figure out a way, you can provide a lot of value.
And I don't know whether this opinion applies to everywhere, but I think what happened was when I first started programming, really the leadership, the gap between data literacy and understanding was huge, right? But now, as we get older, especially if you are a young engineer coming up really in the leadership circle, there are people who have done it or who has an understanding and why that should happen. Yes, of course, we can talk about the entire leadership of the AEC industry, but that gap of leadership, data literacy, and what you want to do is getting better. As an optimistic note.
No, I think that's a great point, and that's why we're so lucky to have someone like you who have gone through this experience with this understanding in this leadership position to kind of pave the path for the next generation, to make it a little bit easier for them to explore and innovate and spend less of their time explaining why they need to do certain things, why they need this amount of time to make this improvement. I think that's huge, right? For someone to not have to both convince and learn and debug all at the same time. But I think as we round out to the end of our conversation, this is a question we always like to ask our guests. Part of the reason we do this podcast, part of the reason why it's named Most Modern, is we're all trying to figure out what era we're in. We're not quite postmodern. We're not quite in this future where we know where we are. But from your perspective, Murat, what would you say is the era that we're in? It's
an exciting era, but I think we are just pre-iPhone era. If you think about the iPhone and how it basically enabled a completely new ecosystem of apps working in one environment in a seamless manner, I think we are just before that. The reason why I think we are going to see an exponential increase in this kind of connectivity, if you want to work with AI models, you want to get the benefit out of it, you need a pipeline, data pipeline, some kind of data environment. The AI agents can work in. Right now, we are not there. People are working on those solutions. But once, enough stakeholders, enough entities have this kind of environments, I think we will see a huge uptick in both efficiency, but also potential for startups out there that work in this environment.
So for someone who listened to this conversation and say, Murat, that's super exciting. I want to come work for you. I want to come work with you. I want to read more about what you're about. Where can people find you?
People can connect me on LinkedIn. I'm not I don't write that often, but at least as a connection point, LinkedIn will be the best place.
If you enjoyed this episode, be sure to subscribe to Most Modern on YouTube and wherever you get your podcast. If you're listening on Apple or Spotify, please leave us a rating and review. It really helps more people discover the show and helps us bring in great guests like Murat. Thank you for listening, and we'll see you next time.
Most modern.
Most modern.
Most modern.
Most modern. 모스트 포던 팟캐스트